Hi everyone, today we are going to talk about performance of Dulux Visor Shield exterior acrylic paint. This presentation is going to include an introduction, videos, and analysis of the experiments with a conclusion to our results.
As acrylic paint is water-based, for comparison we are using Pascal trim oil-based alkyd paint, which is commonly referred to as an enamel paint. These are the two products that would be compared in this presentation.
We conduct 4 experiments to check the performance of the pen compared to its counterpart. The experiment with the acrylic pen will be shown on the left in white color, while the enamel pen will be on the right and is green in color.
This experiment shows the brushes being dipped in the various paints and the relative volume of paint that adheres to the brush bristles. Both paints come up with an excess volume of paint. The paint drips faster back into the tin for the enamel paint than the acrylic paint. The volume of paint left on the brushes is greater for the acrylic paint as well. This can be highlighted as when the brushes have stopped most of the dripping, some of the bristles can still be seen in the enamel paint, whereas the acrylic paintbrush is completely covered. The experiment also shows the acrylic paint is more viscous than the enamel paint. This can be seen by the rate of excess paint falling back into the tins, with the acrylic paint having larger and slower drops of paint. The flow for both the paints is linear with time. In terms of performance, both are desirable as they both succeed in sticking to the brushes with a good volume of paint. However, the higher viscosity and greater volume of paint with the acrylic paint would mean it is preferred.
Paint to have a complete film compared to enamel paint, which is usually only 1 to 2 coats. The water-based paint takes less time to dry, approximately 2 hours compared to the enamel-based paint, which requires 12 hours, and therefore requires less time before the second coat can be applied in contrast to the enamel paint. So single film coating is an important performance metric for enamel paint that is not necessarily for acrylic paint.
We have used 4 common surfaces to which a paint should be able to adhere to. They are wood, brick, plastic, and a metal surface, in this case aluminium. The property being studied here is the adhesion of the paints to different surfaces as a measure of performance. Both paints showed good adhesion to the surfaces, with no flaking or cracks in the film, which shows they are suitable for all such surfaces. The paints have similar spread and gloss levels on 3 out of the 4 surfaces, apart from the metal surface, which gave a thicker film for both paints, and the enamel paint had a higher gloss than the other surfaces. As with the previous experiments, the acrylic paint has more prominent brush marks, whereas the enamel paint is thicker and has a more uniform and shiny film due to its oil-based emulsion. This can also be related to the droplet size of the paint, as the acrylic has a smaller droplet size due to the water than the enamel paint with the oil droplets. Though there are different kinds of paints for different surfaces, the commercial value of the paint increases significantly in regards to the number of surfaces it can successfully coat. This table is from Dulux, giving the comparison of water-based paints on the left and enamel paints on the right. The main points to take from this table are that acrylic paints perform much better when used on the exterior than enamel paints. They are better at keeping colour due to their greater UV durability. They have better ability to cope with expansion and contraction due to weather, and also they have resistance to alkalis. This last point is extremely important, as many buildings employ brick exteriors, and having a paint that would lose adhesion on the brickwork is useless. Enamel paints are more usually used for windows, doors, and trims.
This spread test video shows the spreadability of each paint in length scale. It can be seen that the acrylic paint spreads out further than enamel paint, highlighting the lower viscosity of the acrylic compared to the enamel. The paint also spreads to the entire width of scraper used to spread in case of acrylic paint, whereas the enamel paint form a thicker film and spread less, while it also tears off over a much longer distance. In relation to the performance, this allows us to estimate the paint spread film thickness and the theoretical spreading rate. The spreading rate allows us to give a rough estimate of how many liters of paint would be needed for a given surface area. The acrylic paint would have a larger theoretical spreading rate compared to the smaller wet film thickness of the enamel-based paint.
This is a test of yield stress and viscosity of the paint. The paint is placed on a plastic board using a syringe with 0.5 ml of acrylic paint and 0.3 ml of enamel paint were used due to different viscosity of the paint. As shown, the enamel paint runs down much faster and also thinner film than the acrylic paint due to effect of high viscosity and high yield stress. The yield stress is an important part for performance of paint. If the thickness of film is attained, the force of gravity cannot overcome the yield stress and making the paint stay on the surface. This could also be an attribute of adhesiveness between the surface and the paint, and also the flow properties and microstructure working together affecting the yield stress. The performance of yield stress shows a better application of paint on the vertical surfaces.
This shows that acrylic paint is water resistant. It is important in exterior paint as it means water and snow will not dissolve or break the film. To test, the small film was obtained and measured. This film was placed in boiling water for 10 minutes, and afterwards we can see in the first 2 pictures the film didn't change in length and the thickness of the paint was the same as well. The third picture shows the film was placed in hot water again, but this time it was stirred for a couple of minutes. The third picture shows that the damage on the film was as a result of the tube used in stirring. It means the paint is hydrophobic, which is due to the long polymers that make up the film.
Determining the success of paint includes its ability to stick to surface for a long time and that how well it can spread to form a uniform film. Also, how many different types of surfaces it can efficiently adhere to. This includes how well the paint sticks to the paintbrush or roller. The consumer performance matrix is based upon the look of the paint, while the end-use performance matrix includes factors that are dependent on achieving a good commercial value. These are subjective to people and various job requirements depending on different environmental conditions. Acrylic paints have an edge over enamel paints as you can change the flow properties by adding water. These include the microstructure composition, color, feel, and durability. The paint must protect the material covered, demonstrate good UV durability, weather resistance, and be anti-corrosive to resist any abrasion, fade in color, or mold. Thanks for watching.